Hello and welcome to the R walkthrough of our second video from the series Data Science Made Easy. In the second video of the series, we discussed a bit about exploratory data analysis, and whatever we had discussed in that, like summarizing the data and the central tendencies, we will be using those in R and showing you how to do those things in R. So if you remember from the first walkthrough video, we had used this function called read.csv. I'm using the same function to allot some data into this variable x, and within quotes I am giving a path to the file name, which is, in this case, I'm using an URL. I am giving some additional parameters here as well, which mentions that there is a header in the file, and to import the strings as factors. So let us run it, and it downloads data from the URL. Let's see how does the data look like. Okay, see, so there are no column names. However, I have the information about the column name, so I am assigning the column name to these columns. How do we do that? We use the function names and provide the data frame within bracket and define the column number within braces, and then provide the column name within quotes. So let us run this, and here we go. So we have the English speaker, we have the semester, and we have the class attribute. We are interested in these three columns only. That's why I did not change the name of the other columns. And then we will change these columns into, let's say, factors. In fact, all of them we are changing into factors. And now, after we change them into factors, how does the data look like? It is English speaker, semester, class attribute, and so on. Now, what we want to do is, I want to introduce you to the pipe. What is pipe? Pipe is a very interesting and a very user-friendly tool, if I may say. So what it does is it takes the parameter on the left-hand side of it and passes it to the function on the right-hand side of this one as the first parameter. So if you check out the mutate function, like many or almost all the functions in R, the first element is always the data. So what happens is, it is equivalent to typing mutate x dash and then whatever is written on the right hand side. So this particular pipe function takes the data from the left hand side, that is x, and puts the data as the first value in the function. So what we did here is, we are passing the x value to the mutate function. Mutate means changing something or creating something, and what are we doing? We are creating a column called English speaker, but there is already a column called English speaker, so we are basically modifying the column English speaker. What are we doing? We are saying that if the English speaker equals to 1, that means if, for example, here English speaker is equals to 1, then the value will be yes, otherwise the value will be no. So if I run this, only this portion, then this all became yes and no. So we have used the function mutate, and within mutate we have used the function if else to change the value of 1 or 2 to yes and no. And if you notice, after this again we are using a pipe operator. So this thing that this data frame that you see now on the screen, it will be passed on to the next function, which is again mutate, and Now we are mutating class attribute, and we are using a function called case when to define what the class attribute will be. So if the class attribute is equal to 1, then it will be low. If it's equal to 2, then medium, and if it's equal to 3, then it's high. Don't worry about the different functions that I'm using. Since I'm using it, I'm explaining it to you, but there is a separate video on data manipulation which will cover all these aspects in much more details. Similarly, we are mutating the third column semester, and then we are selecting some of the columns. So after mutating, we have 1, 2, 3, 4, 5, 6 columns, and out of that we are selecting 1, 4, and 6. 1, 4, 1, 4, and 6, and then this value will be allotted again back to x. And if we do that and run x again, this is the data that we get. Now what we will do is we want to find out, if you remember, when we spoke about qualitative variable, if it is a single variable, we always try to count. So let us count the class attributes. So here we had 3 different kind of class attributes, and we are trying to find out how many of each are there, how many are high, how many are low, and how many are medium. And we are using a group by function and then summarize. Don't need to go into details of this one. We have a separate video on data manipulation, and we will cover that in that. Here what I want to focus on is that when you have single qualitative variable, you try to count the number of times they are occurring, and then you display it using a nice graph. That's all. Graphing, again, you do not need to worry about the different functions used here. Those will be covered in a separate video. Here you go. Now, if you remember, when there are 2 variables involved, then we combine those. So let's say no and low, how many times are they occurring? Yes and low, how many times are they occurring? No and medium, how many times are they occurring? Yes and medium, and how many times are they occurring, and so on. This is what we do when we have multiple qualitative variables. We combine the variables and then count the number of times they occur together. And then after we have the data, we just plot it. Here we go. If you remember, in the video I had shown a different kind of graph. I wanted to show you this kind of graph as well. So here it is. So this bar graph can be shown in different ways, and this is one of the ways where I have segregated them into 2 categories first, no and yes, and then within each of these categories I am showing the number of times high, medium, and low occur. Another way of showing the same data is this one. When you show the data in this way, it becomes easier for you to understand which is the subcategory that contributes most to the category. For example, in this one, you see in yes category, the high subcategory contributes the highest. This becomes very easily visible when you draw the graph in this manner. We'll cover these aspects again in a more advanced manner when we talk about graphs. Going further, let us create a data frame. I'm creating a data frame here where I have 2 vectors. So I am using a data.frame function, and I am using 2 vectors to create a data frame. So the data frame looks like this. So in one we have the sex, that is female or male, and the other one we have weight. So now we will show the summaries of the numerical variable or quantitative variable. To do that, the first one, if you remember, we had shown histogram. Here from this graph we can say that most of the people are just below 40 kilos, and here most of the people are just below 50 kilos. So this is how a histogram is used. Now the same thing is also visible in the density plot, where we see most of the students weigh something just below the 40 kilos. Yes, in this one we are comparing the distribution of weights within different sex. For example, male and female. So we see that the distribution of male is in blue and distribution of female weights in red. So in general, the tendency of weight of male is higher in the data set that we have. Going further, this is the cumulative charts. So what we did here is, let me show the data first. It will be easier for you to understand. So we divided into different categories. So first we took some category 30 to 39, then 40 to 49, and so on. And we counted the number of times or number of students there are in the category. And then we did a cumulative count. That means this value is actually 189 plus 98. And again, this one is 110 plus 28, and so on. And this is just the percentage of the total. And if we plot this, this is how the graph looks like. So you can very well say that most of the students in the class are below 50 to 59 kilograms. So if you see here, almost 100% of the students are below 50 to 59 category. Okay, now going further, now we will show the relationship between the numerical variables. So we have a data frame which is basically unemployment rate by year, and this is the data downloaded from the World Bank. So this is how the data frame looks like. This column is the value, that means the unemployment rate in percentage, and this is the year, and here's the country, and this is the country code. Now usually when you have a data set, you first try to find out if there are missing values or not. So missing values are usually denoted by MA, and the way to find out if there are missing values is doing this. So what I did was I used a function called is.na, which actually finds out or tells if each of the elements within X is NA or not. NA means missing. And if something is missing, then it returns a true value, and if something is not missing, that is not NA, it returns a 0 value. And when we add it up, if we get anything more than 0, we know that there are some missing values. And you see that there are 31 missing values in the data set. If you want to check which are those, we can very quickly do that. Let's say, here you go. So these are the values. Now, what do we do with this missing data? Because this missing data is useless most of the time. There are cases when we cannot delete them, but here we can delete them. So we use the function na.omit and then delete all the rows which contains na. And then after that we convert the year column into date. And what does it look like? Now it is date. And then we plot the graph, and we see the relationship between the two variables. On the y-axis it is the unemployment rate, on the x-axis it is the year, and we see that all of a sudden there has been a spike, of course because of the COVID. Now I will show you another very interesting way to plot, just for the sake of showing. I'll not go into details. We can build dynamic plots. By dynamic plot I mean like this. So if you hover on them, they are like it can show some values, and it's basically an HTML plot plotted using JavaScript, but we will cover those things in separate videos. I just want to show you this one. Let me show you another example here. We used already inbuilt dataset called empty cars, and here I am showing the relationship between the miles per gallon and engine power. And if you see, if the engine power is high, the fuel consumption is high. I mean, in this one, miles per gallon means how many miles can it cover per gallon. So you see that it can only cover 15 miles per gallon. Whereas when the engine horsepower reduces, the fuel consumption is better. That means it can cover more miles per gallon. So this is how you try to find out relationship between two numerical variables. Now let us come to central location, average or mean. To use that, we use simple function called mean, and we pass the data. So we are passing the unemployment rate to mean, and the mean unemployment rate of the data set is 5.67. If we talk about median is 5.65. Now, unfortunately, there is no function that calculates the mode in R. So we wrote a function. Again, you did not worry about writing functions at this point in time. We'll just use this function, and we try to find out what the mode is. It is 5.75, which is again not very far from the median and mean. Hence, we can say that this data set tends to be more symmetric, not exactly symmetric, but it is quite symmetric. Now coming to the non-central tendencies. The first one we had discussed is range, and here we go. The range is from 5.27 to 7.11. We spoke about variance. We had a formula which I said is not important to remember because we have a function in R which can calculate it for us, and the variance is 0.09. Standard deviation is 0.3, and the coefficient of variance was standard deviation by mean. So if we run this, it is 0.05. A quick way to run some of the exploratory analysis or the descriptive statistics is to use summary, and it gives some of the information like what is the minimum value, what is the first quartile value, what is the median, that is the second quartile, what is the mean, third quartile, and max. So this is a shortcut to find out some of the descriptive statistics. Now we will calculate what is known as interquartile range, which was not discussed in the main video. However, if you remember the box plot that was shown, there was a main box which shows the 50% of the data which is in and around the median. That is, the middle 50% of the data is described by the interquartile range, and this is 0.19. Now if you want to find out the value of one specific data which is in, let's say, 0.25 percentile or 0.25 quantile range, then this is how we do it. We use the quantile function, and we provide the value that we want to, provide the position that we want to see. So this one gives the 0.25, that is 25th percentile. If you want to see, let's say, 75th one, then you can use 0.75 and so on. So this will return the value of the position that you mentioned here, of the location that you mentioned here. Now coming to skewness. For skewness, we can use the plot function and use the density plot to find out the shape of a data, or we can use the hist function, but it's always better, or in many cases it is better to use the density function. And this is the skewness or Pearson coefficient matrix. If you remember from the video, a value greater than 0 is positively symmetric, which we can see. It is positively symmetric, as you can see from the graph, which is reflected rightly in the Pearson coefficient parameter. Now, going forward, we had spoken about the box plot. So this is an example of box plot where the thick line is the median and the box that you see covers the middle 50% of the data. If you remember the interquartile range, IQR, this value of 0.19, this is the range of this value. So the value at this point and the right edge of the box and the left edge of the box, the difference of the two is given by interquartile range, and this is what a box plot looks like. It gives a lot of information. It shows the minimum value, it shows the maximum value, it even shows an outlier, and the box, as I mentioned, shows where the middle 50% of the population is located. Another way to plot box plot is by using box plot function directly, and you see this one is also a box plot. It shows the minimum range, the maximum range, and the box itself covers the 50% of the middle population, and there is an outlier on top. If you want to see the value of the outlier, you can just use boxplot.stats, then provide the data as a parameter to that and write $ and out, and it says that 7.11 is the value of the outlier, which looks good. Now if you want to find out this particular outlier in our data set, we used another set of code which we do not need to go deeper into now, and it shows the value 7.11, which is the unemployment rate of 2020, which is an outlier. Outlier basically is some value which is substantially away from the other values of the data set, to put it simply. Slide that we had shown in the main video, we spoke about the importance of graphs, and we spoke about a data set where the parameters were very much equal. Like if you see the mean, we're saying the mean of the variables x and y in the data set were same, and similarly variance was same. So what is that data set? If you want to check that data set, it looks like this. There are 4 data sets and x and y values look like this. If you plot them, you see that despite having the same value in some of the descriptive statistics parameters, these are actually completely different data sets, as you can see here. If you are interested, you can have a look at the codes that I have used. These codes will be available in my GitHub page. I will be sharing the links. Well, this wraps up the current video of walkthrough with R while summarizing qualitative and quantitative data. I hope you enjoyed this video and you will continue watching videos from this series. Again, I would really appreciate any feedback that you have, and I would also appreciate you if you support this initiative by liking, subscribing, and sharing it with others. Thank you so much.